Okay, my dear students in grade 11, hi. By the name of our God Allah, today we come to study a new subject, which is section 3 in chapter 1. We studied 2 sections in chapter 1, and today we come to study third section, which is about the falling objects. Falling objects then. What's the falling object? Falling object means moving down objects like this. For example, this marker is moving down. This marker moved down. So this is a falling object. The moving object from a height called free falling object. Today we come to study this free falling object. Okay, first, student, let me define the free falling. Free falling means the motion of the object under only its weight, or under only the gravitational force, the gravity, which is equal to 9.81. So here, student, we have the acceleration equal to 9.81. Okay, so this is the free falling object. Any regarding or neglecting any other factors like air resistance, like other factors, other forces. So here we have only one force, which is equal to the gravitational force. Okay, so then you remember we derived some equations for four equations for the motion that called kinematic equations for the motion of the object. Now today we come to derive again these kinematic equation for free falling object. If you remember, student, our equations were delta x, let you write down there here. Delta x first equal to 1 over 2 V final plus V initial all time delta t. This is first. Second, it was V final equal to, okay, V initial plus I delta t. Number 3, okay, delta x equal to V initial delta t plus 1 over 2 I delta t squared. Okay, final equation were V final square equal to V initial square plus 2I delta x. Okay, so then this is for general equations, for kinematic equations for the object. But today, here for free falling objects, then instead of delta x, we have delta y. Why delta y? Because the motion is downward on y-axis. So we come to replace all delta x here, and here by delta y. This is first point. And instead of a here acceleration, we have g, the gravity that's constant. So let me derive again and write down these equations for the free falling object. So instead of delta x, here we have delta y, and 1 over 2 V final plus V initial all delta t. Equation number 2, V final equal to V initial plus I. Instead of I, we say that we have G delta t. Instead of equation number 3, delta x becomes delta y, and V initial delta t plus 1 over 2 I becomes G delta t squared. Number 4, student, final equation, we have V final square equal to V initial square plus 2G delta y. So our equations for kinematic equations are these 4 equations. Okay. Now, student, let's take some important notes about it. Okay, always, student, because the motion is downward. For example, when you have an object here and here ground. Okay, the object moved down. So delta y is negative. Be careful about these notes, student. About these notes. First, delta y is negative. Always. Be careful. Delta y is negative. Point number 2. G constant, which equal to how much? Can you tell me? Okay, negative 9.81 meter over second square. Why negative 9? Because the motion is downwards. No, the motion is downward. So always G equal to negative 9.81 meter per second square. Okay. On other point, student, when the object ejected, thrown upward, always, student, for the object, for example, here we have at this point, the object ejected upward. So we have V initial, positive V initial. Why? Because it ejected upward. Okay, till it reached the top point. Here, top point. At top point, student, when the object, for example, this marker is thrown upward. I am throwing this marker upward. Here, this point is upward. At this point, this upward point, V final becomes 0. Why? Because the object becomes at rest or stops for a moment due to the gravity. The gravity decreases its velocity that's directed upward. So at top point, velocity becomes 0. Be careful here. At this point, student, this point, V final equal to 0. So third point, you have at top point, V final or the velocity equal to 0. Okay, student. Now, when the object ejected upward, as we said, the object here stops at top point. After that, what happens to the object? What happens? Because we have always the G, the gravity, so the object change its direction and move down. So here, student, it changed direction and moved down. And its velocity step by step increases. But here, the velocity becomes negative. Why? Because it's directed down. So, student, V final always negative. Is negative. Why negative? The direction of the final when it's moved down becomes negative because it's directed down. Okay, other point, student. Other point. Okay, when the object, for example, here moved upward. At this point, and the object returns down. At this level, student, this level, at each horizontal point, V initial or V final equal to minus V initial. Okay, let I explain for you. Okay, for example, when velocity here at this point equal to, for example, 3 meters per second upward. Okay, when the object returns down and reach this point, its velocity becomes same to this velocity that was 3 meters per second square, but becomes in inverse directions, opposite to it. If velocity here, for example, equal to 3 meters per second, at this point, velocity becomes negative 3 meters per second. So, at student, horizontal points, at any points, when the object reaches, after it returns down and reaches the same point, V final equal to negative V initial. V final equal to negative V initial. Okay, this point then was important about the free-falling object's motion. Okay, now student, let's come to draw. Okay, to draw the velocity or the motion of the object. Okay, the acceleration. For example, when we have student here, this coordinate is for velocity. This is for t, time by second, student. Velocity by meter per second. Okay, here we have 0. Okay, now let's explain our case. First, when the object ejected upward, the velocity, here we have maximum velocity that directed her. Now, when the object, for example, has 12 meter per second velocity, here 12, for example, here 9. For example, here you have 6. Here you have 3 meter per second, here 0. And here becomes -3, -6, and so on. Okay, student. Now, when the object ejected upward, its velocity, initial velocity is 12 meters squared. And velocity decreases gradually, step by step, decreases. So you have this line gradually till it reaches 0. Here, student, who can tell me what's this point? What is this point? This point, student, is maximum point or top point. Here, student, here, top point, at top point. The diagram of the velocity. At top point, student, velocity becomes 0, as we said here. When the object reaches the top point, its velocity becomes 0, so it's equal to 0. Okay, now after that, this interval, student, this interval for moving up, the velocity decreases from 12 to 9 to 6 to 3, after that to 3 at top point. After that, it changes its direction and moves down. Here, this interval is for moving down. So this is the acceleration or the motion of the object. This line is for the acceleration. Acceleration, as we said, equal to g. G equal how much? Then always equal to -9.81 meters per second squared, which is equal to the slope. So g equal to the slope of this line equal to -9.81 meter. This is all about the free falling object. Clear, student? Okay. Now, my clever student. Okay, look with me to your book in page 26. Page 26, you have sample problem 1F, falling object. Okay, free falling object. So sample problem 1F, page 26. Okay, we have student. The question said, Bawan hits a volleyball so that it moves with an initial velocity of 6 meters per second straight upward. If the volleyball starts from 2 meters above the floor, how long will it be in the air before it strikes the floor? Okay, Bawan, student, let me draw our case. First, Bawan here on the floor. Here, this is the ground, student. Ground. This is the floor. The height of the floor, how much? Is equal to 2 meters. 2 meters, the height of the floor. So our given, student, write down your givens equal to h height delta y. Delta y, as we said, student, because the motion here downward, here he ejects a ball upward, but the ball finally moved down till it reached the ground. So delta y, here delta y is negative. Delta y. So delta y -2 meters. This is first, be careful about the y, delta y, the direction of delta y. This is first. Second, student, initial velocity, because the ball, student, here ejected upward, so 6, the initial positive 6 meters per second square. As we said, we have g, which equal to -9.81 meters per second square. So our givens is these givens. The question asked about what, student? About delta t. So find delta t. Yeah, student, how we can solve this question? Let me return to our equations. We have these 4 equations. Okay, first, as I told you, which equation can we use in order to find delta t? Okay, let me start from this equation. This equation includes delta t. But here we don't have the final. We don't have the final. So we cannot use this equation. Let me come to this equation. This equation also includes delta t, but we don't have the final. So we cannot. Also, student, delta t here, we have delta t. The initial delta t. Also, we can find delta t, but it's more difficult, complicated, this equation. And we have this. So, student, first, let me find the final using this equation. After that, we come to use our v final that given here or found here in one of these equations in order to find delta t. Clear? Okay, we come to use these. After that, we come to use our result, our v final here in order to find delta t. Okay, so then solution v final square equal to v initial square plus 2g delta y. Okay, v final square. V initial how much? 6 square plus 2 times negative 9.81 times negative 2. Okay, so we get then by using mathematical steps, you know, v final as in your book, the result how much? V final which equal to negative 8.7 meter per second. This is the final. Okay, for finding the delta t, we come to use this equation, second equation, student, which is delta t equal to v final minus v initial over g. Okay, so v final how much? Negative 8.7 minus 6 over g, negative 9.81, and we get 1.5 second. So this is the delta t for this flying of the ball. Clear, student? Okay. Your homework, student. Okay, practice 1F homework. Practice 1F. Okay, questions are easy. Try to find the, okay, question 1, 2, 3, and 4. Question 1, 2, 3, and 4. Also, section review 1, 3, which is how many questions? We have question 1, 2, 3, and 4. Okay, only these questions 1, 2, 3, and 4. Try to solve these questions. Okay, student. And also we have chapter review. Try to solve chapter review. Questions in chapter review. Okay, you have how many questions? Okay, near 46 questions. Try to solve them. After that, you have important questions in page 36, which is student standardized test prep. Test prep. Or multiple questions, standardized test prep. Okay, we have near 9 questions. Okay, let I give you the results or the answers. Question 1, student, the answers. Answer for question 1, B is true. Question 2, A is true. Question 3, D is true. Question 4, C is true. Question 5. B is true. Question 6. 6B also. Question 6B. Question 7. 7C is true. Question 8B is true. Question 9 is D is true. Okay, my dear student, we finished your chapter 1 and I hope you for getting full marks and study more in order to get more. Okay, see you later. Bye.